Bismillahirrahmanirrahim. Allahumma salli ala Sayyidina Muhammad wa ala ali Sayyidina Muhammad. Assalamualaikum warahmatullahi and a very good day to all my beloved student. Alright, so today we continue. So this is chapter 2 form 5. So chapter 2 form 5 KSSM. This is about pressure. Okay, so in this chapter we will have 6 subtopic. So we have liquid pressure in liquid, atmospheric pressure, gas pressure, Pascal principle, Archimedes principle, and Bernoulli's principle. Okay, this will be a very interesting chapter. Okay, not hard and interesting. Alright, so we first look at pressure in liquid. Okay, 2.1 pressure in liquid. So what does it mean by pressure in liquid? Actually, liquid has pressure in it. Okay, so if you look at the dam, so they design the dam to generate electricity. Normally for hydroelectric, they design the dam by make sure the base of the dam will be thicker compared to the upper part of the dam. Okay, let's say like this. If let's say the picture that you see here, so this one is from the top view. Okay, top view. But from the side view, you will see the design will be like this. If you can see from the side view, like that. Okay, let's say. So this part is the water, let's say. So you can, and then this is the concrete structure, this part. So they normally design the concrete structure with thicker at base. Here will be thicker. Upper part will be thinner. Okay, so the base, they made this thicker due to the pressure in liquid at the lower part is higher. Okay, and then here doesn't need too much strength, so they reduce the thickness of the dam. Okay, so number 1, we have this formula for pressure. Okay, I introduced already in chapter 1. So P equal to F over A. And then another formula for pressure is this. P equals to H rho G. Okay, so P equals to F over A. So this is a general formula for pressure. Okay, pressure acting on the surface is equal to force acting on the surface divided by the area. But pressure in liquid have a special formula. We have P equals to H rho G. We actually can derive the pressure in liquid formula from two formula, which is P equals to F over A and rho equal to M over V. Now, where do you get this formula from? This one. Okay, so this is actually come from, this is actually a density formula. Okay, density equal to mass over volume. Alright, so come we look at this. Okay, so what we need to do is to fill in the blank to derive formula for pressure in liquid. So we have the diagram here shows water, and we just pick a column of water in a cuboid shape. Okay, where we have this the height of the water column, which is in cuboid shape, and then base here is the area. Okay, now. Okay. So the volume of the column, okay, the volume will be equal to base, okay, base area times the height. So it means that I can put here as A times H. A times H. Then the mass of the water column, so from formula density equal to mass over volume, so I can write mass equal to, bring V to the other side, so rho V. So I can put here rho V. Like that. And then the weight is equal to mass times gravitational acceleration. Mass times gravitational acceleration. The mass here you get from this. So just salin from here. So rho v g, because g is the gravitational acceleration from last year form 4. And then pressure at the base of the liquid will be, this actually come from this basic formula just now, P equal to F over A. Okay, so F is equal to the weight of the water column. So W will be the weight of this water column, the weight. So the weight of that water column, liquid column, will be equal to this, rho Vg. So we can write here, rho kan, from this part, P sama dengan W over A. So W now is rho Vg over A. Okay, like that. Okay. And we can simplify where V is equal to AH. AH here is V times G divided by A. So where do I get this AH? It's actually come from here. This part here. So I can simplify. Just cancel A. So the formula become rho Hg. So this is formula for pressure. Nampak? Okay. So given here is H rho G. This part H rho G. But just now we have P equal to rho H G. Pun boleh ubah susunan. So just bring H in front. Become like that. Okay. So from here, it means that we already derived the formula of pressure in liquid from P equal to F over A, and also from here P equal to F over A, and from the density just now. Okay, so the formula become H rho G. Okay, so I need to memorize that formula. And then from this formula, we can say that there are three factors that affect the liquid pressure, which are depth of the liquid, density of the liquid, and the gravitational acceleration. Okay, remember the three factor. Okay, so if you are asked to calculate liquid pressure, or pressure in liquid, so use this formula. P equals to H rho G. Remember that, no? So H must be, H is the depth of the liquid, rho is the density of the liquid, G is the gravitational acceleration. And then a reminder, when you want to use the formula, make sure the unit that you use is standard unit. What I mean is, if the density of the liquid is in kg per cubic meter, okay, so the depth of the liquid also must be in meter. And then the gravitational acceleration should be in meter per second per second. Okay. You cannot use macam depth of liquid in centimeter. Cannot. Jangan. So the depth of the liquid mesti in meter. If you use, if let's say given is in centimeter, make sure you convert it to meter first. Then only can calculate direct using the formula. And then the SI unit for pressure is Pascal. Okay. So 1 Pascal is equal to 1 Newton per square meter, or 1 kgm negative 1 s negative 2. How come it's like this? Still remember my video for chapter 1? Okay, how to derive that? So standard unit, SI unit for pressure is Pascal. Actually from the formula kan, P equal to F over A. So we know that F is Newton, unit Newton, area unit is meter square. So we can simplify this, bring m up, the unit become n m negative 2. From there we know that 1 Pascal is equal to 1 Newton per meter square. Then how to derive another unit here? This one senang. So since you know already force, alright, I just start from the beginning lah. P sama dengan F over A. So F is equal to kg m s negative 2. If you still remember, the formula for force is mass times acceleration. So mass is kilogram, acceleration is ms negative 2. Okay, so that is the same as force divided by unit for force divided by the area. Area is m2. Can bring m2 up, so it become kg, okay, m1, okay, m1 here minus 2, so means that m negative 1 and then s negative 2. That is how we get the formula. Alright, so hopefully you can understand this part. Boleh faham, eh? Just playing with the formula. Now, as you know, the formula for pressure in liquid is P equal to H, okay, depth of the liquid, times the density of the liquid times the gravitational field acceleration. So it means that the pressure in liquid is affected by three physical quantity, which is the depth. This is not height. If you define this, make sure you define it as depth of the liquid, and then density of the liquid and the gravitational field acceleration, or we call this as gravitational acceleration. So if let's say I want to plot graph of P, pressure in liquid, against depth, or pressure in liquid against density of the liquid, and then against the gravitational acceleration, so it means that the responding variable are all pressure. How will my graph look like? Okay, so here we know that P is directly proportional to H, P also directly proportional to the density, P also directly proportional to gravitational field acceleration, gravitational acceleration. So the graph should start from origin and it should be a straight line graph from origin. Now, if let's say we want to prove this conclusion, so we need to do experiment. Okay, so in your textbook we have two diagram here. Okay, the apparatus setup here. So this apparatus setup is to determine what factors affecting pressure in liquid. Okay, so the first one here is depth of the liquid and pressure in liquid. And then another one down here on page 42, your textbook. So this is density of the liquid and pressure in liquid. But the apparatus given is the same. Nampakkah sama kan? Okay, same apparatus setup. Yeah, same apparatus setup. Okay, in this experiment, you need to use these are the apparatus material that you need to use. Of course, you need ruler. Okay, so here you have ruler. Then you have a liquid that is placed in a tall container. Okay, then you have a U tube. Okay, we call this as manometer. Contain liquid. Okay, colored liquid, so that you can see the difference later clearly. And then connected to rubber. Okay, rubber tube. Okay, rubber tube, and at the end you place a teaser funnel, and then you can use rubber sheet lah. Okay, down here. Actually, if you open this also no problem. If you don't use this also can. Okay, but we just place the rubber sheet here to make sure the water does not enter the tube. Actually, if you are not using this, also the water will not enter the tube due to the gas pressure. Okay, now, so when just like now, the teaser funnel is in the air, it means that now this part is exerted by the atmospheric pressure. Hence, you can see that this part, okay, the left side of the manometer is acted by the atmospheric pressure. So it means that the pressure acting here. Okay, here. And then this part is open. Okay, the left arm, the right arm of the manometer is open. It means that open to the surrounding, which means the atmospheric pressure also acting at this side. So since both sides, the pressure acting on both sides are the same pressure, which is the atmospheric pressure. So the level of the liquid in the manometer on the left and the right arm is the same. So sama, so means that pressure now is the same. Okay, no difference in pressure on the left and the right side. Now we need to immerse the tissue funnel in the liquid. See what happens. Okay. Alright, so immerse the manometer in the liquid and see what will happen. Tunggu sekejap. Can see that. So you can see that the liquid on the left arm, okay, which is connected to the tissue funnel, move lowered down. And then the liquid on the right side, the right arm of the manometer, move up. So do you see the difference in the liquid level now? So actually the difference in the liquid level here, you measure this different on the ruler, measure this. So this difference in the liquid level on the left and the right arm of the manometer represent the liquid pressure at this depth. Okay, so we measure the depth of the water from the surface to that point. Is it clear? Okay, so both experiment to determine the relationship between pressure in liquid and the density of the liquid, and also to determine the pressure in liquid and the depth of the liquid can be done by using the same apparatus setup. Is it clear? If not clear, please comment below. Okay, this is another apparatus set up for us to determine the relationship between pressure in liquid and the depth of the liquid and also the density of the liquid. So you can actually make yourself, okay, by using bottle, okay, tall bottle like this, and then make hole, okay, lubangkan. Okay, and then you can use either plasticine or sellotape. Okay, paste here. This part katakan dah berlubang, just put plasticine or sellotape. In this case, this is already designed by using another tube like that. So, you add in liquid in the container. Okay, so let's say this is the surface of the liquid. So the depth of the liquid need to be measured from the surface of the liquid. So let's say we have point A, B, C. Okay, so A is here, so it means that the depth of point A is shallower compared to point C. So it means that C is the deeper because we measure from the surface of the water, not from the base. So I can say that here will be shallower. This is deep, this is deeper. Alright, so since we already have water inside, and then the upper part of the bahagian atas is open to the atmospheric. Okay, means that atmospheric pressure is acting on the top lah. Alright, so if let's say we remove the plasticine here, what do you think will happen? Okay, if we remove plasticine, okay, from point A, point B, point C, what do you think will happen? Yes, correct. Yeah, the water will spurting out. Okay, water will spurting out like that. Okay, will spurting out. So, but will there be any difference between the distance of the water spurting out? Okay, between that 3 point A, B, C. What do you think? What do you think? So, yes, there will be difference in the distance. Okay, so we look at this. Okay, watch that. The other one. Do you see the difference? Okay, do you see the difference or not? Can see, right? The point C, the distance of the water spurting out from point C will be the longest. Point A just now is the shortest. That's right. So actually the distance of the water spurting out, you can measure by using ruler. So that represent the pressure in liquid. So the greater the distance of the water spurting out, so the greater the pressure in liquid at that particular point. Alright, so it means that we can have two apparatus set up to investigate relationship between pressure, what factors affecting pressure in liquid. Okay, so hopefully you can understand that. Alright. Okay, so this is an experiment to determine the relationship between the pressure in liquid and also depth. Okay, so look at this.
There are some pictures of us measuring the cups after their return. We repeated the initial measurements of the cup. So once again, we measured the cup height, the top diameter, the mass, and the volume of our cups. Here you can see there were in fact changes to the cup. The cup on the left was not sent to the bottom of the ocean, therefore this is the original size of the cup. The cup in the middle went to a total depth of 198 meters or 594 feet. And the cup on the far right went to a total depth of 2,500 meters or 7,500 feet. The results of our experiment showed that depth was related to the amount of change seen in each cup. Depth did have an impact on cup height, top diameter, and volume, but no impact on the mass of each cup.
Okay, isn't that amazing? Okay, the same cup brought down into the ocean with different depth. You can see the size of the cap decreases. Okay, the mass is the same, the size decreases. Okay, due to the huge pressure in liquid. Okay, this is interesting, right? Alright, now look at this question. So diagram 3.1 shows a diver in the sea. Okay, the same diver in the sea. So 3.1 in the sea, and then 3.2 same diver at deeper position. Okay, remember we measure the depth from the surface of the water. Alright, so we always measure depth from the surface of the water. In this case, this is the depth h. And then the second diagram, this will be the depth. Then he noticed that for both his ears feel uncomfortable, means that feel painful, rasa sakit due to the pressure of the seawater. Okay, so from that observation, you need to come up with an inference and hypothesis. Okay, inference hypothesis. Then using apparatus such as Siphon, U-tube, container, rubber band, rubber sheet, and other apparatus, describe one experiment to investigate the hypothesis that you already stated just now. And then in your description, so make sure you write your aim, the variable, list of apparatus material, arrangement of apparatus material, and then how do you the procedure of the experiment, including one method of controlling manipulated variable and one method of measuring responding variable. Then you tabulate your data and analyze your data. Alright, so the experiment can be done in physics lab once you go back to school. But before that, I'm interested to discuss for the inference and hypothesis for this problem diagram. So from here, okay, now we already know there are two variables involved. One is the depth, the other one is the pressure. So feeling uncomfortable in ear represent pressure. So when you write your inference, you can write pressure in liquid. Okay, pressure in liquid is affected by the depth of the liquid. Or in this diagram, you can also say pressure acted by, to the diver is dependent on the depth of the diver dive in the sea. Pun boleh. But I prefer student to write straight to the point, okay? A simple one, so that you can write your hypothesis easily. Okay? So you can write your hypothesis as the greater the depth of the liquid, the greater the pressure in liquid. Okay? So when you want to write your hypothesis, no more talking about the sea or the diver. Okay, so just straight to the point, talking about pressure in liquid and depth of the liquid. Okay, now I have another diagram here. Can you guess what is the inference for this? See, the same diver, but now first diagram, swimming pool. Second diagram, seabed. And then they are at the same depth, but 3.2, so this one, feel sick, painful in the ear. So now the depth is the same, so means that if you use this formula, P equals to H rho G, so H is the same. Okay, H is the same. Means that the constant variable is H, constant variable. And feeling painful in the ear will be the pressure in liquid. So this is your responding variable. Which one is your manipulated variable? Can see here. Density. Why density? Because swimming pool is fresh water. So the density of the swimming pool will be less compared to density of the seawater. So the manipulated variable will be the density of the liquid. So if you look at the question pun sama just like just now. First you need to write your inference. Inference will be the pressure in liquid is affected by the density of the liquid. And then hypothesis, the greater the density of the liquid, the greater the pressure in liquid. Then you see here, plan experiment using this apparatus, tissue funnel, tall beaker. So this will be the same apparatus set up as in your textbook. Here, alright, so you have U-tube, we call this as U-tube manometer, and then connect to the silicone tube. Here they give you silicone tube, but you can also write rubber tube, no harm. Okay, and then using the tissue funnel, and then rubber sheet at the end of the tissue funnel, and you use measuring cylinder. If you just write tall container pun boleh terima, and then here is the liquid. Alright, so when you immerse the tissue funnel at a certain depth, so you see there will be difference in the liquid level on the manometer. So the arm that is connected to the tissue funnel like this, here, so the liquid will be lower. Because why? So here got pressure in liquid, right? This part got pressure in liquid. So that pressure in liquid will push this part turun ke bawah. So means that pressure here is bigger compared to that side because this side is open to the atmospheric. Okay, boleh faham? So when you write your inference, just like what we discussed just now, so pressure in liquid depends on the depth of the liquid for this case, and then the greater the depth of the liquid, the greater the pressure in liquid. And then your aim, please read your textbook sama. Pressure relationship to study, to investigate relationship between depth of liquid and pressure in liquid. Right? So manipulated is depth of the liquid. Responding, pressure in liquid. But we represent it by calculating the difference in the height of the water column D between the two level in the U-tube. So means that between the two arm of the manometer. Alright, then the constant variable here will be density. So the apparatus material, just write what you have in the diagram. Don't forget the ruler. Here, if it's good to add in ruler. Cikgu betulkan your textbook. It's good to have a ruler here. Okay, you draw yourself, tambahkan. Okay, so how do we do the experiment? The first thing that is important is you need to immerse the tissue funnel into the measuring cylinder until the depth 4 cm. So this is actually the first manipulated variable value, 1 mark lah. Then you need to determine, measure the difference in the liquid level on the left and the right arm of the manometer, and then you record your data. Okay, then you repeat, okay, with 4 more reading. Then this will be the table. Alright, the table for you to tabulate your data. Okay, see, I have 3 things here: name, symbol, unit. Here will be name, symbol, unit. This is important for your practical test. And then after that, you need to plot graph of D against H. What is D? D is the difference in the liquid level in the manometer. Okay, H is the depth of the water. So on page 42, this experiment is to determine the relationship between pressure in liquid and the density of the liquid. Alright, so as usual, so this one cikgu just pergi dengan laju. Please read yourself. Hampir sama with the experiment above. Okay, it's just that the responding variable, the manipulated variable is different. This is density. Okay, depth is the constant variable. So now you know when we do experiment, can look at the formula like this. Alright, so pressure is the responding variable. If let's say the depth of the liquid is the manipulated variable, so these two will be density and the gravitational acceleration will become the constant variable. Is that clear? Hopefully this is clear. Okay, so this is for density and also the pressure in liquid. Alright, next, look at this. So when we have a bottle, okay, the bottle need to be open like that. Then we have, let's say, more holes poked on the bottle. So can see that the water spurting up. And then the distance of the water spurting up from the base of the bottle, if the depth of the water is the same, depth is the same, so the distance of the water spurting up will be the same. So we say that pressure at a point in the liquid will act in all the direction. Okay, so ke semua arah, and they have same pressure. So means that pressure in liquid is actually acting in all the direction. Okay, akan bertindak ke semua arah. Okay, so this diagram shows apparatus, okay, that have different shape. Okay, the vertical column have different shape. So if let's say we add in water inside, you will see that the level of the liquid will be the same, sama. And then let's say we have point A, point B, C, D, and E. So we say that pressure acting at point A, B, C, D, E will be the same. Okay, semua akan sama. Because why? Pressure in liquid is not affected by the shape of the liquid. The pressure in liquid only affected by three factors: depth of the liquid, the density of the liquid, and the gravitational acceleration. So if let's say we do experiment on the moon and on the earth, so the pressure acting on the earth will be pressure acting in liquid on the earth will be greater compared to on the moon. Alright, because of the gravitational acceleration in the earth is bigger. Okay, so for this apparatus setup, so this is to prove that pressure in liquid is not affected by the shape of the liquid. Okay, semuanya akan sama provided the depth of the liquid is the same. Okay, we can use this YouTube manometer to compare the density of two liquid. Okay, so look at the first one. So liquid X, okay, is in YouTube manometer, right? And you can see that the upper part is open to the surrounding. So it means that on the left side here, atmospheric pressure is acting, PATM. On the right side also, the same atmospheric pressure acting. So that is the reason why there is no difference in the liquid level on the YouTube manometer. So means that pressure on the left and the right side has the same pressure. So means that same level in the liquid in the manometer, left and right arm, means that same pressure. Now we look at the second diagram showing we have liquid X. At the same time, we have liquid Y. They are not mixed. Okay, so when you add in the liquid that have different density, they will not mix. Okay, does not mix. Now, so how to determine the density of liquid X and Y? So here, actually, we can use this method. remember I told you that when the point is at the same level in the same liquid, so the pressure acting at that point will be the same. So do you see from this diagram, we have point A and point B that is at the same level. So we say that pressure at point A will be the same as pressure at point B. Boleh faham? Okay, I show you another diagram. Alright, so now we can see that A and B is at the same level. Alright, same level like that. Aras yang sama. So we can write the pressure at point A is the same as pressure at point B. I can also write PA sama dengan PB instead of using 1 and 2, just like this in your textbook. Alright. Now, so since this is about pressure in liquid, so we can use formula H rho G, left side, right side. And then on the left side will be the height of the liquid is H1, put 1. And then the density will be liquid X lah. Okay, means that 1 represent X. So here can put X. Alright, G will be the same. And then on the right side, we have height of the liquid, means that the depth of the liquid, measure from the surface of the liquid. The depth of the liquid is H2 on the right side. Here. Then the density will be the density of liquid Y. So 2 here, I can put Y. Alright, so the formula become P like that. Here is Y. Okay, so H, density liquid X times, and then equal the H, okay, on the right side times the density of liquid Y. So from here you can compare. If let's say, okay, now can see from here, by measuring the height of the liquid, what I mean is the depth of the liquid on the left and the right arm, you will be able to compare the density of liquid X and liquid Y. So from the diagram here, and relate to the formula, so which liquid has higher density? Which one? How to solve that? Now you see, H times density X is the same as H2 times density Y, right? This formula. Means that the value here will be the same. If here is katakan 1000, on the left side hasil darab will be also 1000. And you can see obvious H1 is bigger. So H1 is greater compared to H2. H2 is smaller. And they are equal, right? Density X times density Y. So which means since the value, if you times the H and rho the same, so it means that now the density of liquid X is smaller. Density of liquid Y is greater. Boleh faham? Okay, so hence we can conclude that since H1 is greater compared to H2, so we say the density of liquid X is smaller compared to density of liquid Y. Hopefully you can understand this. Kalau tak faham, please write below, okay? Okay, move on to page 45, your textbook, KSSM Form 5 textbook, alright? So, solving problem involving pressure in liquid. So, we already know this formula, pressure equal to depth times the density of the liquid times the gravitational acceleration. So, we use that formula to calculate pressure at a depth in a liquid. At the surface of the liquid, it also experiences pressure. So that will be when you want to calculate the actual pressure acting on the object in the water, so we need to use this formula. Okay, don't get confused, Alright, because why? P equals to H rho G is only for pressure in liquid. But don't forget, on the surface of the liquid, there will be atmospheric pressure. Okay, boleh terima? So, P atm is equal to the atmospheric pressure. So, the value of atmospheric pressure is huge. So, here, can see 100 kilopascal. So at sea level, the atmospheric pressure is equal to lebih kurang 100 kilopascal. Now look at this. Okay, so this is the sea level. Alright, so here is the sea level. Sea level. So it means that pressure, atmospheric pressure acting on the sea level. So here I put P atm equal to 100 kilopascal. Alright, so let's say we dive in the ocean. Katakanlah we dive in the ocean at this point. So here will be acted by pressure in liquid. Okay, pressure in liquid. So the pressure in liquid is equal to H rho G. You can calculate from the determine the depth of the liquid here. So the total pressure, if the question asking you about total pressure, P total, ataupun the actual pressure acting on the diver at certain depth like this, so you need to total up. Okay, P atm mesti campur dengan pressure in liquid. Alright, so the unit for pressure here given is in 100 kilopascal, but there are other unit as in meter water. So a standard value for atmospheric pressure, if you use unit meter water, it will be equal to 10 meter water. Alright, so let's say the depth of the let's say the depth of the diver is 50 meter water, so I can also give value like this. So P atm is 10 meter water plus 50 meter water, so equal to 60 meter water. This is another unit. I will explain in more detail, inshallah, how we get this unit. Okay, meter water in next lesson, inshallah. Alright. But let's say you want your answer to be in kilopascal, what you need to do will be to determine the pressure in liquid by using this formula. H will be the depth of the liquid, which is 50, and then density will be the density of the liquid, okay, which is water will be 1000 kg per cubic meter, G will be 10. Alright, so this value you get 503010. Okay, so this value plus the 100 kilopascal, then you will get 100 kilopascal. Kilo means 3. Alright, like that. So the answer is, this is 500, this is 100, so it will be 600 kilopascal ataupun 600 pascal if you want the unit to be in pascal. Alright, so about the unit, we'll discuss more in next lesson, inshallah. Okay, look at example 1 in your textbook. So figure shows fish at the depth of 1.5 meter in an aquarium. 1.5 meter, wow. So this is a huge aquarium, 1.5 meter. Sama tinggi dengan cikgu. Alright, so the density of the water given is 1050 kg per cubic meter, and then the atmospheric pressure is 100 kilopascal. So you are given the gravitational acceleration as 9.81 meter per second per second. So the first question asking, what is the pressure experienced by fish caused by the water, only the water around it? Then the next question asking, calculate the actual, means that the total pressure acting on the fish. Now, see, so the first one, just use this formula. P equals to H rho G. So we know that H is 1.5 meter, and then the density of the water given, and then G is also given. Straight from the formula, substitute the value, you will get your answer in Pascal. Alright, in SPM, you don't have to change it to prefix like this unless needed. Okay, until here pun dah cukup dah. Until here. Alright, so the pressure acting on the fish by the water only is 15450.8 Pascal. Then next question asking you to determine the actual pressure. So if they ask you about actual pressure, you need to consider the atmospheric pressure. So pressure acting on the fish here is actually acted, the total pressure acted by the liquid, and don't forget P atm. Alright, and they give you P atm as 100 kilopascal. So the answer for A plus P atm, just like that. So here can see the value here campur dengan P atm. Right, because here they give you in kilopascal. Actually, if you write in pascal also no problem. Okay, so harap boleh faham. Okay, next question showing a U-tube filled with water and olive oil. Okay, so we have water, blue color, and then olive oil, peach color, like that, to differentiate. So the density of the water is given 1000 kg per cubic meter. So calculate the density of the olive oil. Okay, so when you see this diagram, the first thing that you must have in your mind will be same liquid, same level in the same liquid. Right, same level in the same liquid will have same pressure in liquid. So here you need to focus on this part. This part. Sama level left and right arm. So if let's say we label this as A, this as B, so we can say that pressure at A will be the same as pressure at B. And see what is on top of B and A. Like that. Then senang kan? So can use this formula. H rho G, left and right side. Okay, so just substitute the value. So G will be the same, so you can cancel G. G boleh dipotong because the value is the same. Now H1 will be this 15 cm. H2 is 16.5 cm. Alright, so you get this equation. You see, since the unit on the left side for the height, depth of the liquid is the same, centimeter, so you don't have to change it to meter. Just leave your answer in centimeter like this lah. Because why? Later you calculate, you can cancel also. And finally, the unit will be the same unit as the density on the left side, like that. Alright, so here, when you substitute like this, so this is mark 1, and then your final answer, correct unit is mark 2. Hopefully boleh faham, alright? Okay, in our daily life, we actually apply a lot of pressure in liquid. Okay, so you look at this diagram, okay, this picture showing tank is normally placed at top of the house. This is not electric tank. If electric, then you need to pump by using electrical energy. But now this one, you don't have to connect it to electricity, and the tank should be placed at top of the house. So you see, the water tank usually placed at the space between ceiling and also the roof. And then the difference in the height between water level in the tank and water tap produce high water pressure acting on the tap. So it means that here, let's say, this is the water level kan, and then the tap is down here. So the difference in the, here actually the depth from the surface of the water in the tank to the tap. So here got difference in depth, so it means that it will create more pressure. Okay, so it means that the water can come out more and faster from the tap. Okay, so water flows at high speed when the tap is turned on. Alright, the second one will be this. I believe you always see this, right? Okay. Alright, so a bag of intravenous liquid is placed at a position higher than the body of the patient. Kan? Nampak? So the liquid level will be here. So there will be a difference. So that's why the bag should not place on the bed. Tak boleh letak atas katil lah. It must be hang, digantung higher. Alright, so the pressure due to the difference in height of the liquid column will push the intravenous liquid into the body of the patient. So here, so the difference here, difference in the height, or I can say difference in the depth, create bigger pressure. Alright, so the bigger the difference in depth, alright, the bigger, I put here difference in depth, the bigger the pressure acting, and the liquid can go into the patient's body. So the rate of flow of the intravenous liquid into the patient's body depends on the height of the bag hang. Alright, so it can be controlled by the adjuster. Okay, sometimes you see nurses, they control the dipping, okay, by adjusting this part. Alright. So next one will be the dam that we discussed earlier. So the structure of a dam built thicker bawah. Here is thicker compared to the upper part. Okay, built thicker at the base because water pressure increases with depth. Alright, so the thicker section of the dam will enable it to withstand high water pressure. Alright, boleh. Now I can see that the penstock here, is at lower section so that the high water pressure will produce fast flow of water into to drive the turbine. Okay, what is the use of the turbine? We will look at we will learn about this in detail for chapter electromagnet. And then the use of siphon is used to transfer water from higher region to lower region. Okay, you can try this. Okay, high region to lower region. Which one is high region? The aquarium. Okay, so it means that water from the aquarium can be removed, right? Here, one end of the tube that filled with water is placed in the tank at higher position, while the other end is at lower position. So the flow of water from end D, produce region of lower pressure at point B. Okay, so atmospheric pressure push water into A. So here, atas ada PATM. Okay, so when the water come out here, so this part have smaller pressure. Alright, so the PATM is greater, right? Will push the water into A. Right, it go up. Okay, boleh faham? So hopefully you can understand this. Alright. So with that, see you in next lesson for more exercise, inshallah. Alright. Okay, till then, Assalamualaikum warahmatullah.